Hello everyone, and welcome to my third video on my journey to teaching concept-based math. My name is Mr. E. Let's get started. I'm going to take a quick look back at what we've covered so far. First video, what is concept-based math? Second video, but the first video on unit planning, I covered the first 3 steps in my planning process. And you're here. The second video on unit planning, generalizations. And as always, my goal is that you leave these videos with something that you can actually use. In this case, completing parts of your concept-based unit plan. All right, so again, today we'll talk about generalizations. We've covered 3 parts of the process before, and we'll cover 1 more after this one. So what are generalizations? Generalization is 2 or more concepts stated in a relationship. A generalization begins with students will understand. Compare that to many objectives that start with student will do, or be able to do, or student will know. A generalization answers the questions. What do I need to learn this? Why do I need to learn this stuff? How am I ever going to use it? According to Lynn Erickson, generalizations are universal, timeless, and abstract. It's what takes students to a higher level of thinking. When writing generalizations, we want to avoid what she calls no-no verbs. No-no verbs include affects, impacts, influence, is, are, and have. So my source for generalizations is Engage New York, and it's free. Great resource. So for example, again, we're working with congruence. Went to lesson 11. Found this statement. Students know that to prove 2 figures are congruent, there must be a sequence of rigid motions that maps one figure onto the other. Let's see if we can write that with no no-no verbs. Student will understand that a sequence of basic rigid motions creates congruent object. Let's go back and put that in our thinking map. So here we have 3, could have more. Here we have 3 generalizations, and this one even came with the video. Let me share that with you. So here we have the 3 rigid motions, and that final red object or red image is congruent to the first one. Likewise, went to Engage New York and pulled some generalizations from those books as well. And here is another free resource from Desmos on dilations. All right, so we're moving right along. We have our generalizations for our unit web, for congruence, similarity. Well, some of you may be wondering, what are these micro concepts? Well, generalizations are what students should understand. Micro concepts are what students should know. According to Dr. Jennifer Wang Wathaw, math is a conceptual language. Therefore, our definitions in math are also concepts that students must know. Even the definitions in mathematics are concepts. So again, back to Engage New York, plenty of concepts, plenty of definitions. I'm going to plug a few of those in. So some of our micro concepts for congruence. And what's the connection? Well, you have to know, or students have to know, the micro concepts in order to grasp the generalization. Same with similarity. Have to know what a dilation is before they can come up with the definition or understanding of what similarity is. So micro concepts and generalizations go hand in hand. All right, so we've added our generalizations, our micro concepts, and the next video, and I hope you join me there, we're going to add the statement of inquiry. And just a brief summary of what I've used in this video: 2 free resources, Desmos and Engage New York. And I encourage you to invest in these 2 books, Concept-Based Math by Jennifer Wathall and Concept-Based Curriculum Instruction by Lynn Erickson. All right, that wraps up video number 2 in unit planning. Hope you enjoyed it, hope you learned something. And please join me for video number 3 when we talk about the statement of inquiry. Talk to you soon.